Hello, welcome to today's video. I haven't done any videos in a while because I've been sick. I've got I have bronchitis and a bit of pneumonia, and I got some medication for it. Finally went to the doctor. But anyways, enough about me. We've got, this is a little prototype that I made at work. It's just a coil and 6 LEDs on here. And it's a PCB trace that's just wrapped around, and then it has a little inductor. And it was done as a proof of concept for design, and we actually used it, but not this board, but same kind of thing. But I've got my wireless charger hooked up to my phone here. It's just sitting there, and if I put the coil here, you can see that it starts lighting up the LEDs. And this is how I did my proof of concept at work. I have one of these chargers. Why are you not focusing? Focus. Focus. Anyways, I've got one of these wireless chargers at work, and so this is what I use to prove the proof of concept. So if I take the phone away, you'll see that it starts blinking as it's trying to find the phone. And then if I put my phone back, if I get it lined up again, and it says, oh yeah, we're charging, maybe. There it goes. Now it's charging. But anyways, that was what that does. And so I've been playing with wireless power transfer. I've had an idea for a board game that I've wanted to adapt for a while. But this is the same exact coil, but it's just, there's no LEDs on it. I just got it upside down here. Soldered the wires onto it. And then this is that same LED coil, and it works either direction. And it gets pretty bright. I've got the function generator here running at about 500 kilohertz. That's what's driving the coil, and I got the output on the scope here. So, back to my original thing here. There's a board game called Acquire, and it's one of my favorite board games, and we do like game nights and things like that. And it's got a bunch of these little tiles. I've always wanted to make a nice little digital version of this where the tiles light up, so when you place them next to, you know, if you're the Yellow Corporation, you place, this guy's got 7i, so when you place 7i, place that tile there, it should turn yellow, because all these guys are connected. All these guys would be yellow, you know, that one would be white, these guys would be red, the ones up there would be green, the ones over here would be blue, this would be like cyan, orange, and magenta, right? Purple. But yeah, so what does that have to do with this? Well, I made this little board here. And this little board is essentially this, but I have an RGB LED. Actually, I have 2 RGB LEDs on here. And they have a little LRC filter. So, to show you what that is, this little board schematic here is this. So, this coil is the function generator driving, and then I've got red, green, and blue LEDs, and an LRC circuit, where the inductance is the same across all of them, the resistance is the same, and the capacitors are 1C, 2C, and 4C, and I literally have 1 capacitor, 2 capacitors stacked on each other, and then 4 caps stacked on each other there. And all that means is, ta-da, we get green. Now, I'm going to take the frequency on the function generator, and we're going to turn it up slowly, and you can see we can get yellow. And then if I keep going, we get a nice red. And if I keep going, we get a nice magenta color, which is really hard to tell on the camera. And then if we keep going, we get blue. So that allows me to generate a bunch of different colors. I could flip it around. You can kind of see it's blue. It's kind of hard to see on the camera because it's pretty bright. So you can turn that back down through all the different ranges. Oh, you know what I could show you here. We'll go back up to blue here. So blue is roughly 1.6 megahertz, and then if I turn it down red is somewhere in the middle here, about 1.4 megahertz, and you'll see I've got a nice red there. And then if I turn it down some more, we get into, if we go around to like 500 kilohertz or so is where the green is. So green is about 500 kilohertz, red is about 1 megahertz, and blue is about 1.5 megahertz is what the math should have been, but it's off a little bit, probably because there's extra inductance in the coil, and I didn't take that into account because, it just needs to be close. Anyways, we'll keep that running around in there. So just leave it at 500 kilohertz. So one of the things we need to be able to know is we got to detect that a tile has been placed, and that's easily done by, if you look at the scope, if I lift it up, you can see there's a pretty decent change in my sine wave, and that allows me to detect that somebody has placed a tile. So the only issue that I've got now is, the whole point of this is there's 96 tiles on here, so it goes I through 12, so A, B, C, D, E, F, G, H, I, J, or A through I and 1 through 12. And I didn't want to have like 96 microcontrollers with a wireless inductance power with some kind of communications protocol and all that kind of stuff, because you want to be able to throw these around into a bag and just have them either epoxied or acrylic or some kind of clear, maybe frost it so that you don't see the electronics in there, so when you place the tile it lights up and be like, oh, it's amazing. But the board would have all the little sending coils in it. It would just be one big PCB. Micro would be, the micro that runs everything would be over here with all the drivers. So you have row column drivers with little tank circuits so that the micro wouldn't have to actually generate the frequencies. We just turn on and off different tank circuits to get all of the coils to oscillate. And then to do like different colors, we'd probably do a red pass, a green pass, and a blue pass, and hopefully that would be able to refresh fast enough that that it looks pretty decent and it doesn't flicker or anything. The only issue that I have so far is when you place these guys, I don't quite know how I'm going to detect that. Those can light up too, like say if I placed, so if I've got the base tile already and I place the company, corporation, or hotel, depending on what model of or version of the game you've got, when you place that, it could still light up. Problem is, it's very hard to detect. If you look on the scope here, so that's me moving the upper one. It's a very small amount, so as compared to the base, is got a pretty big jump. So I'd have to experiment with that to figure out if that would be enough for it to detect that that you place that on top of there. Screensaver. So that's one thing. The other thing it could be is you could have like a certain section on the game board where say this is the company or the hotel, and when you pick it up, it knows that you picked it up, and then it can go to some kind of high gain mode to look and see where it's been placed. But that's the only thing I've got right now that's kind of an issue, is finding out where you placed the company to actually assign it. Because these would be like white tiles until you place the blue one on there, and then it would become blue, and then when you place 9i, it would become blue. Once the game knows that that group is that color, any tile that's placed next to it would obviously do that. And then you can make things flash or do stuff for safe companies. If you try to place a tile which merges two that are too big, there's all these cool little rules. But you essentially buy stock in the company. If you don't know about Acquire, go to Wikipedia, look it up. It's a really cool game. And yeah, it's like a stock market. You invest by building your company out, and you can buy stock in other people, and you can help them and sell stuff. And yeah, it's kind of cool. But anyways, that's what I've been working on. Oh, and for those that are wondering about the tail controllers, yeah, I'm still working on it. I've just been spending a lot of time writing code at work, so I'm not really motivated to come home and write more code. But here, if I can show you that there is a sine wave. It does wag. I have all four of them just going. So anyways, I'm going to go into a coughing fit. So that's the end of this video. Thanks for watching. Bye.